In this video, we'll talk about conditional probability. And conditional probability is one of those things that historically is difficult to understand, and I think that's due to how it's presented. So I think that in a lot of ways, people jump right to the formula and people get lost in the notation. So what we're going to do first is we're going to look at an example, kind of talk about what it would mean in context, and then we'll talk about the formula. So let's say we run a survey and we ask 1,000 people if they like cats or if they like dogs. And let's just say it shakes out like this just to make the math a little bit easier on ourselves so we can talk about the concept. So in this case, we have cats, 300 people of our 1,000 liked them, 700 don't, just as a number. Okay, and then we sample 600 people like dogs, 400 people don't. Both ways we have 1,000 people. Now if I ask you, what's the probability that someone likes dogs if they like cats? And that is a kind of a weird question to ask, because we're asking, okay, if someone already likes cats, what's the probability that they also like dogs? Because there is some overlap. Now, not all 300 of these people are going to like both. Some of them are going to fall in here. And that can be a little bit tough to determine. So the idea boils down to, we're going to look at the probability of that someone likes cats and dogs, and we're going to divide that by the probability that they just like cats, because I only care about those 300 people. That would be my total in that case. So how many people would have an overlap? And how I would do that is I would have to take, remember, and in this case I have to take the probability of cats times the probability of dogs divided by probability of cats. And it is possible for this that we would need some more information on how much, or I guess the probabilities of it. This would just kind of motivate the example of where it's coming from. So the idea is, in this case, we're looking at 300 out of 1,000 people like cats. So we're looking at 30%, or I can write it as 0.3. And then I'm going to take that times the probability of the dogs, which would be times 0.6, and then I'd have to subtract off the probability that there would be both, and that's going to be the part that I'm missing for right now. I would need that extra piece of information to be able to actually answer this question. How many people, or what would the probability be that they like both, or even just how many people like both? And then I would divide that amount by the probability of the cats, the 30%. And that would calculate the probability, and that is what conditional probability is. It's this whole part of having a condition at the end. What's the probability that A happens given that this event has already been done? So let's talk a little bit about notation. Now this is the part that I think causes the most confusion with this, is that they lead with the notation historically, and we're not so much looking at a contextual problem, at what the core of probability or conditional probability is. So the way they will write it, and it's a little weird, so we have the probability of B given A. That's what this little line means. And what that means is probability that B happens if A has already happened, is another way you can think about it. And that would kind of be in our example, given that someone likes a cat, what's the probability they like dogs? It's the idea of, okay, if I'm looking at that pool, just at this particular example of that group, how many people would fall into this group? And sometimes the answer can be fairly intuitive, and sometimes the answer can be counterintuitive. It's kind of difficult. This is where probability kind of gets a little weird. And the way we would do this is we would calculate the probability, kind of like we were talking with the cats and the dogs, probability of A and B, and divide that by the probability of A. So another way you can think about it is if you're going with the formula approach, the probability of A is your denominator, and then the probability of both happening will be on your numerator. Now that's the notation, that's the formula. If you prefer not to think of it that way, that's fine. I just know that a lot of textbooks, they use this kind of notation, and I just want you to be aware of it. So let's look at an example here. In this case, we're looking at what's the probability I roll a 3 given that I've already rolled an odd number. So in this case, probability that I roll a 3 would be what we'd consider to be our B in the formula. And then the probability of A, my condition, would be the probability I roll an odd. So I have to think about the probability that I would roll a 3 would be 1 out of 6th, and the probability that I roll an odd would be a half. And then I just follow the formula. So I'm going to take the probability of the 3 given the odd would be equal to the probability of B, so 1/6 divided by the probability of the odd, 1/2. That'd be my condition, so that would go in the denominator. So I would simplify it. I'm going to essentially divide 1/6 by 1/2, so I'm going to rewrite that as, or with the division symbol, which I can rewrite that to be a multiplication problem, and that would be 2/6 or 1/3. So if I've already rolled an odd, or given that that first roll was odd, was the probability that it would be a 3. That's how we're looking at it. So the idea is if I roll an odd, what's the probability that it is a 3? And it would make sense in some way that it would be 1/3, but however it can be counterintuitive depending on how it sounds.